quick. Power property would be something like, what if I had the common log, or the log, of 3 raised to the 7th power? I could throw that 7 out in front and make this 7 times the log of 3. This problem is going to look a lot worse than what it looks now, but we're practicing the properties on stuff like this, so later on when we solve equations, we know how to use the properties and we're fluent with them. So you'll be like, why are we doing this? That's why. So that ultimately we can solve equations using these properties. Right? So the first thing I'm going to do is notice that this is division. Right? I'm dividing. So whenever I see division inside of a logarithm, I know that I can break that up into the log base 6 of the numerator, 5x cubed, minus the log base 6 of the denominator, which is y. So that would be the first step I would do if I was trying to expand this expression. The product property, I end up with the log base 6 of 5 plus the log base 6 of x cubed minus the log base 6 of y. Lastly, now that we've broken it up using the product property, I can make this into the log base 6 of 5 plus, now I can take that 3 out in front here using the power property. So 3 times the log base 6 of x minus the log base 6 of y. What I'm going to do on the second one is I'm going to break it up using that division property, or the quotient property, because I'm dividing. So this will be log base 6 of 3x squared minus the log base 6 of 5y cubed.
Does that say negative 3x squared over 5y cubed, or is that like...
So once again, just like I did before, I can't use the power property yet, but I can use the product property, so I'm going to break this into the log base 6 of 3 plus the log base 6 of x squared. Then I can also do the same thing to the other equation, right? Because I've got 5 times y cubed over here. So it's going to be minus the log base 6 of 5 plus the log base 6 of y cubed. I can take that 2 and throw it out in front, so it'll be plus 2 times the log base 6 of x, all right, and then minus the log base 6 of 5, I can't do anything with that, and then remember I've got to distribute this negative right here, so it's going to be minus the log base 6 of y, minus 3 times the log base 6 of y, right, because I took this 3 and I put it out in front. So this is a multiple choice question. That's wrong. So we're going to use our properties to take this mess right here, this log 9 whatever, to take that and simplify it. Alright, so I'm just going to rewrite it here. So we've got log of 9 plus 3 log 2 minus log 3. Okay. Before, when we were expanding these things, the very last thing we did was the power. We took the power out in front. What do you think the first thing is going to be if we're condensing them, if we're going the other way? So our first step will be to move this power, this 3, into the exponent of the 2. So we'll change this to log of 9 plus log of 2 cubed, 2 raised to the 3rd power, minus log of 3. I've got log of 9 plus log of 2 cubed. I think that changes to the log of 9 times, isn't 2 cubed 8?
Yeah.
All right, 9 times 8 minus the log of 3. So I'm going to simplify this to log of 9 times 8 divided by 3. All right, so that's the log of, what does that all simplify to? 72 divided by 3, which is 24, I think, right? So then the correct answer was,
Log of D.
We're going to deal with the powers. I'll go through this one a little bit quicker because we just did one like it. But I'm going to deal with the power first. So I'm going to kick the 2 up into the exponent. That'll give me natural log of 8 plus the natural log of 5 squared minus the natural log of 10. And so I move the power from out in front of the logarithm up into the exponent. The thing I'm going to do is I'm going to see that I'm adding 2 logarithms right here. And so I can condense them into one logarithm if I change from addition to multiplying the things inside of the logarithm. So this will be the natural log of 8 times 5 squared minus the natural log of 10. Real quick, 5 squared is 25. The last step here is we're going to divide. We've got subtraction, so we're going to divide on the inside of one logarithm. We're going to have 8 times 25 divided by 10. All right, and that simplifies to be the natural log of what? 20. Good. Take a second, copy down this. These are called the change of base formulas. They're really kind of offshoots of the same thing. Why does this come in handy? Why is this helpful? Well, before, when we had things like the log base 2 of 8, oh, that's a bad example, of 11, we didn't really know how to handle that, right? We don't have a calculator button for log base 2. But what this allows us to do is to change this into something like the log of 11 divided by the log of 2. Now, I have a log button, so I can punch this, the top and the bottom, the numerator and the denominator, into my calculator. Log base 3 of 8. All right, well, that's a situation where I couldn't put it into my calculator, right? So I can use the change of base formula. I'll use the first one, or the top one from the previous slide. Log of 8 divided by the log of the base of the original, which was log of 3. Type that into my calculator and see what I get. Make sure you close your parentheses on the 8. What do you get for log of 8 divided by log of 3?
1.89.
1.89. Now let's go check the other formula and see if that one works. So we'll try the natural log of 8 divided by the natural log of 3. What is that?
1.89.
1.89. It's magical.
What?
All right, last one. So if I have log base 6 of 24, I'm going to use the natural log on this one. Like I said, it's shorter to write. Natural log of 24 divided by the natural log of 6. And what do you get when you plug that into your calculator? 1.77. So just to reiterate, this gives us a way to deal with logarithms of bases that are not very nice. Alright, so like I said, using the change of base formula, we can handle something like this. So I'm going to make this the log of x divided by the log of 3. Right? And that's something that I can put in my calculator. When you put it into your calculator, it's going to look like, y equals the log of x, close your parentheses, divided by the log of 3. Alright, so hopefully you got something like that graph in blue. And when we think about the domain and range, obviously we're going to do the domain first. Alright, so the domain is all x values for which there's a corresponding y value. In other words, look at the x values. If there's no graph at that x value, then it's not in the domain. So if I check something like negative 2.5, is negative 2.5 in the domain?
No.
No, because this graph never goes past the y-axis, right? It gets really, really close to it, but never crosses the y-axis. So the domain is going to be all x's that are greater than 0, right? From 0 to the right. Now the range, it goes from the bottom of the graph down as far as you can go, all the way up to, well, this is going to actually keep rising forever. So the range is what?
All real numbers.
Yeah, the range is all real numbers. Written like this is the natural log of x plus 1. Okay, so it is not the natural log. In other words, the 1 is not inside the parentheses.
X greater than 0.
Yeah, domain is going to be x greater than 0, and the range, sorry, they happen to be the same, but the range is all real numbers. Yep, that was the end of 7.4, and now you've got 7.4, 7.5. It's all been covered. And here's your assignment, 503 and 510. This assignment, just put all of it on one. That's one assignment right there. So you've got two assignments, the 5.41 and this one.